Hello, algebra students. This video is made especially for 8th period since you were going to miss class today and you had an assembly, but anybody could watch it. It's relevant to what we're doing, but here we go. So we're going to be talking about the real numbers today. Now, let's review really quickly from yesterday. We had to talk about rational numbers and irrational numbers. Well, the rational numbers, they were like numbers like this. You saw them in blue. You should have this in your notes already. 6, negative 15, 3/4, the negative of the square root of 9. Remember, the negative of the square root of 9 is really just negative 3 in disguise, right? Because the square root of 9 would be 3, and then the negative of that would be negative 3. 6 and 25 hundredths. We don't say 6.25 anymore. We say 6 and 25 hundredths. 10, square root of 100 is really 10. 0. 4 and 17 hundredths, but the 7 is repeating. 3 and 14 hundredths. Okay? Those were the rational numbers. And remember, the rational numbers had 3 important characteristics. The 3 important characteristics are dun, 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 all fractions. 2, decimals that terminate. Yeah, decimals that terminate, and also decimals that repeat. Yes, that is absolutely true. Okay, those were the rational numbers. And we also talked about the irrational numbers. Oh no, my airliner is out of control. Pi was an irrational number. 4.1793 dot 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 was an irrational number. The square root of 20 was irrational. Why? What made them irrational? Well, they had a major characteristic here. Hold on, we're moving when we shouldn't be. Please stop. Oh dear, I'm having so many problems. I can't get it to stop moving. I don't know what's happening. All right, so let me see here. The characteristic was the decimals that never end nor repeat, like pi. It goes on forever without repeating. Square root of 20. There is no square root of 20. You can estimate it with a decimal that never ends or repeats, but there is no number times itself that equals 20 exactly. So therefore, it's an irrational number. Okay, why don't we take a minute here and we'll guess on a few numbers. I'm going to go ahead and pause while I get some more numbers up here. Hold on one second. I don't see my pause button. Pause? Where are you? Pause. There we go. Okay, I'm back. Hopefully you didn't miss me too much. So here's some numbers. I want you to pause this video and decide if they are rational. The Q stands for rational. It's a symbol. You'll see that later in the video again. And I stands for irrational. I can explain why later if you would like to know. So all I want you to do is write these numbers down in your notebook and then decide if they're rational or irrational. All right, go ahead and pause the video and do that, and then I will show you my solutions. So for rational numbers, here come my solutions. If you haven't tried it, go ahead and try. Here are my solutions. If you have a number that is a fraction, it is automatically rational, right? That is part of the definition of a rational number. All fractions are rational. They also include decimals that end or decimals that repeat. Now, is negative 35 a fraction? Well, it could be written as 1. It could be negative 70 divided by 2. That would make it a fraction, yeah. Or is it a decimal? Yeah, you could say it's negative 35 and 0/10, right? You could put the decimal point on here like this with a 0. It's a decimal that ends. Or you could say, well, there's an infinite number of zeros. Well, now it's a decimal that's repeating. So it doesn't matter. It's rational any way you look at it, okay? The numbers that are irrational are like pi. They're decimals that go on forever without repeating. Oh, look at that, negative 6. Uh-oh, lost my I symbol, my irrational. Or the square root of 18. There is no number multiplied by 18 multiplied by itself that equals 18. Excuse me, I misspoke there. There is no number multiplied by itself that equals 18. That makes it irrational. So hopefully you were able to get all of those correct. All right, now we're going to move on to the new material, and that's called the real number systems. The rational numbers and the irrational numbers are subsets of what we call the real number systems. Okay? Now, the rational numbers get broken down into like special categories that you're more familiar with. they start with the natural numbers. The natural numbers. They have a symbol, and like that with an extra bar. The natural numbers. Okay, and the natural numbers start with 1, and they go 2, 3, 4, and they go on forever. They do not include fractions or decimals. There are no fractions or decimals that are natural. 0 is not a natural number. -2 is not a natural number. Natural numbers, lowest number is 1. They go 1, 2, 3, 4, and they go on forever, and they are an infinite set, okay? Then there's the whole numbers. Now the whole numbers aren't quite what you think. A lot of people misunderstand the whole numbers. The whole numbers are exactly like the natural numbers, except they include the number 0. So the whole numbers go 0, 1, 2, 3, 4, and they go on forever. Still no fractions, still no decimals, no negatives. The next set are the integers. The integers. They have a symbol, and it's a Z. We don't use I because you saw me use I for irrational numbers. These are the integers. Okay? And the integers include the whole numbers, the 0, 1, 2, 3, 4, on forever. But here is where the negative numbers come in. Now, they're not negative numbers, they're the negatives of the whole numbers. So you see there's still no fractions, no decimals. The integers are all the whole numbers, 0, 1, 2, 3, 4, on forever, and they're negatives. Hopefully you wrote that down. Integers are the whole numbers and they're negatives. There's no fractions or decimals in the integers, okay? Now, after the integers, we get to a familiar system, and those are the rational numbers, right? Together, these all make up the rational numbers. So, a really good picture, it's called a Venn diagram, where you put the natural numbers in the first circle, and then the natural numbers expand. They get a little bit larger. What color did I use? I used green. Okay. They get a little bit larger, and so we put a circle around there, and that's where the whole numbers come in. Okay. So that means every natural number is automatically a whole number. It's not true that every whole number is a natural number. Can you think of a counterexample? Yeah, that's right, it's 0. 0 is whole, but not natural. Every other number that's natural is whole. Every other number that's whole is natural. Doesn't work for 0. And then we get to the integers, because the integers are just like the whole numbers. They include 0, 1, 2, 3, 4, on forever. But they also include the negatives of the wholes. They do not include -2/5, -6 and 25/100ths. They don't include those. So, if I'm a natural number, say like 3, does that make me a whole number? It sure does, because the green circle goes around the 3. The blue circle goes around the 3 because it's in the blue circle. It's in the blue set. It's a natural number. But it's also a whole number. It's inside the green circle because the blue circle is completely inside the green circle. It's also an integer. So you see 3 is a natural number, a whole number, and an integer. All right, then we get to the rational numbers. 3 is also rational. If it was in our little club, right, it would be in our little club. It would have gotten invited up. I think 8th period, Chris was holding the 3, right, and he got invited to the front of the room, okay? Any number that is natural is automatically natural, whole, integer, and rational. Now, the irrational numbers are their own special group off to the side. They were the numbers in the back of the room, right? They don't have any subsets over there. Now, altogether, These sets make up what we call the real numbers. Yes, they make up what we call the real numbers. That's supposed to be a rectangle, and I didn't do it very well. Sorry, it's kind of a funny looking rectangle. That looks a little bit better. Not incredible, but better. I guess I can take that away. All right, very good. So let's get some practice with this. Let's see if we can identify all the subsets that a given number belongs to. So let's see if we can do that. Hold on a second here. I want to pause my video. Okay, so I've got some sample problems here for you, and your job is to figure out if the numbers are natural, whole, integer, rational, irrational, or real. Now, there's not one answer for any of them. All of these numbers fall into at least two different sets. I will do two of them for you, and here's how it works. So 7, we should all know that 7 is a natural number, right? Natural numbers start with 1, 2, 3, 4, 5. They go on forever. So therefore, I'd eventually hit 7, so an n comes down here by the 7. Now, because of that Venn diagram, if it's natural, it has to be a whole, right? If I'm in the natural circle, 7, I'm automatically in the whole circle. So it's not just a natural number, it's also a whole number, it's also an integer, and it's also rational. Now, one thing you might not realize is it's also a real number. Okay, so the number 7 belongs to all of those groups: natural, whole, integer, rational, and then real. Okay, now the number 4 I'll do for you is the negative of the square root of 49. Well, the square root of 49 is 7, so this in disguise is -7, right? -7 is definitely not a natural number. No, because they start with 1. It's not a whole number either, because whole numbers start with 0. It is an integer, because -7 is the negative of the whole number 7. It makes it rational. Oops, I'm taking these from the wrong place. Silly Mr. Laurence. Kicks are for trids. All right. Oh, I didn't clone them. Is that why? That is exactly why. All right. Oops, I don't want to do that. Group it, and I'm going to infinitely clone it. And the real numbers, I'm going to infinitely clone. So put the reals back, put the rationals back. All right, so I said 7 had to be an integer, and I did have it. No, I didn't have it marked yet, so I'm going to grab a Z. I'll do this with my mouse pad. Oops. There we go. So it's an integer. It is rational. And of course, it is a real number. Dun, 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 dun. There we go. Okay, so I'd like you to pause the video and try to finish this on your own. There's 6 problems left for you to do. Same idea. Write it down in your notebook. Write down for number 2, -4/5. See if you can determine. And then I will show you my solutions. Okay, here come my solutions. If you haven't tried it on your own, please do. -4/5 is not natural, not a whole, not an integer. They do include negatives, but they don't include negative fractions. Only the negatives of the whole numbers. So that makes it rational. And of course, it is also real. Okay, 6.34 ... is, I took them from the wrong place again. Silly Mr. Laurence. Oh dear. All right. Number 3 is a decimal that never ends and never repeats, forcing it to be irrational. Now, irrational numbers are real numbers. They fit inside that real rectangle. Okay. I'm just putting Q and R back. There we go. Okay. I've already done number 4. Number 5, square root of 10. There is no square root of 10. There is no number times itself that's 10. That makes it irrational. And it's a real number. Number 6, not natural, not whole, not integer. It's a rational number because it's a repeating decimal, and it's real. -5 isn't natural because naturals start with 1 and go up. Can't be whole because wholes start with 0 and go up. It's an integer. It's rational. And it's a real number. Okay, number 8. It's definitely a whole number because whole numbers start with 0. All right. Since it's in the whole circle, it must be in the integer circle. I don't have a z, z, z. I don't know where my z's are going. I know I'm picking them up, but they're not following me. There he is. Okay. He's also rational, and he's also real. Okay, there you go. If you like, go ahead and give that homework a shot. You'll be a little bit ahead of the game. Hopefully we won't have too many more interruptions. But that's it for the video. Mr. Laurence signing off. Have a good night, everybody.